Every 10 years, the US astronomy community puts out a plan for how to spend their money, what telescopes to build, and what to send to space. They've just released the latest edition, an ambitious report called ASTRO2020. So in this video, let's look at the highlights and see where some of the leading astronomers think we should be spending money in order to advance astronomy, drive astrophysics, and build some super cool telescopes. The ASTRO2020 report, which this decade has the full title Pathways to Discovery in Astronomy and Astrophysics for the 2020s, is the latest decadal report from the American Astronomical Society, and it outlines the scientific and foundational priorities and funding recommendations for the next 10 years. This report has hundreds of contributors. Both amateur and professional astronomers submit papers and proposals, and answer surveys in order to give their opinions on what the next decade should look like for American astronomy. While this is all about the future of American astronomy in particular, it will have worldwide influence, as America is still a big player in global astronomy. And we know that these reports have a history of producing influential results. Previous decadal surveys recommended launching the Hubble Space Telescope. Chandra and Spitzer were also recommended. And the 2000 survey recommended launching the JWST mission, which will finally launch at the end of 2021. And the Vera Rubin Telescope, which was previously called LSST, and the Nancy Grace Roman Telescope, which is planned to launch in around 2027, were also recommended by previous surveys. So if you're a telescope, being recommended by a decadal survey gives you an incredible chance of actually being built and launched. The report even has some plans in it to make sure that projects don't run horribly over budget, like some of the recent missions. JWST, we're looking at you for this one. So the ASTRO2020 report, what does it actually say and what does it recommend? Well, it's a 600-page document, and it makes recommendations for small, medium, and large-scale initiatives, both ground and space-based observatories across the electromagnetic spectrum, as well as for newer windows into the universe, such as gravitational waves and high-energy neutrinos. Admittedly, I haven't quite read all 600 pages of it, but they do have some handy release notes to tell us all the key details. ASTRO2020 identified 3 main priority areas to develop during the 2020s. The first of these is called Pathways to Habitable Worlds, and says that one of the major goals of the next 10 years should be to identify and characterize as many Earth-like exoplanets as possible. This includes direct imaging and taking spectra of their atmospheres. 2 things which are incredibly exciting. Are we alone is one of the biggest and most inspiring questions we can ask. And finding planets like the Earth that have a good chance of producing the conditions required for life as we know it gives us the best chance of answering that question. The second priority area is called New Windows on the Dynamic Universe, and it tells us the importance of going beyond just light for looking at the universe. While different wavelengths of light can offer us a broad and exciting view of the universe, many astrophysical objects also emit gravitational waves, neutrinos, and other particles. By combining observations from these newer probes with more traditional electromagnetic probes, we can hope to understand a multi-messenger picture of the universe, and try to see events through multiple observing channels. In 2017, we observed a merger between 2 neutron stars, with both gravitational waves and electromagnetic follow-up, which saw light emitted by the merger. In the future, we could even hope to see events such as nearby supernova with 3 probes: gravitational waves, neutrinos, and electromagnetic follow-up, which would be incredibly exciting. This area also aims to probe things such as polarization in primordial gravitational waves, which gives us a window to studying the earliest times in the universe, including cosmological inflation. This time period can't be probed with light, so it has to be done with something other than light, such as gravitational waves. The third and final priority area is drivers of galaxy growth, with the goal of probing the details of the cosmic web of gas and galaxies. The hope here is to understand the evolution of the universe, see how the structures we see in the universe today came to be as they are, and what processes were required to leave the universe as it is now. The rest of the ASTRO2020 report then goes on to explain how we should actually achieve these scientific goals. I'll briefly cover all the main recommendations here, and let's start with the next flagship mission that they suggest. What is the Hubble or JWST of ASTRO2020? Before the report was published, there were actually 4 potential candidates for the recommended flagship mission. An exoplanet imager called HabX, a UV, optical, and IR telescope called LUVOIR, an X-ray observatory called Lynx, and Origins, a mid and far infrared telescope and spectroscopic instrument that would probe the history of the universe. However, for the final report, none of these finalists were actually chosen. The flagship recommended, which will be the satellite launched after Nancy Roman, is given in terms of what scientific goals it should aim for, rather than picking just one from a list. It will be cheaper than some of the options and more expensive than some of the others. Of course it will be a space telescope, and should be an all-purpose IR, optical, and UV observatory, more than 6 times more powerful than Hubble and capable of incredible resolution in all of these wavelengths. Both JWST and Nancy Roman are primarily infrared telescopes, so a mission like this is seen as more of a direct successor to Hubble, which is an optical telescope. Part of the appeal of a mission like this is that it provides data and images that's useful to a huge range of astronomers, so none of us are left feeling left out. In order to get an ambitious telescope like this designed and built without going horribly over budget and within a reasonable time frame, which here means launch in like the 2040s, the report also outlines a different approach to this. The idea is to work out what the mission should do, which they've done, and then develop and design the technology required to do those things before anything is actually built. And once all of the technology exists, only then should we design the final architecture of the telescope, allowing for rapid construction at the end of the process. This is different to how things were done for telescopes like JWST, which was more of a design the thing, start building, and then we'll just figure out what technology we need along the way and design and develop it alongside construction of the telescope. And this approach is probably a large part of the reason that the telescope is so late and so expensive. Also, there are recommendations for the flagship mission after this one, which they say should be an advanced far infrared mission or an X-ray observatory, so that this technology can be developed alongside the current flagship. And this can avoid huge delays between launches as well, like we've seen between Hubble and JWST, and like we will inevitably see after Nancy Roman launches. There are plenty of other major ideas too, beyond just the flagship space mission. For ground-based astronomy, the report, perhaps unsurprisingly, recommends buying into existing plans for extremely large telescopes here on Earth. Telescopes that are currently in operation tend to have mirrors that are between about 8 and 12 meters, but the next generation ones, like the ones recommended here, have mirrors that are between 25 and 40 meters. Remember that bigger mirrors just mean better images. One telescope under construction is the European Extremely Large Telescope. I know, cool name. Which will have a 40-meter mirror, but it might not be accessible for the American astronomers this report is aimed at. Instead, recommendations are made to buy into plans for the 25-meter Giant Magellan Telescope in Chile, and the 30-meter telescope. Buying in means they pay some percentage of the building costs, and in return, American astronomers would be guaranteed time using the telescopes. However, the 30-meter telescope is currently being developed on Mauna Kea, a Hawaiian volcano that is sacred to the Hawaiians, and they're quite rightly protesting the construction. It seems like a pretty bad idea to me to build a telescope on a sacred volcano, so as much as the telescope would produce amazing images because of its location, it's quite easy to be Team Hawaiians on this one. So this telescope might, and probably should, be moved and built somewhere else, or abandoned totally. If it is abandoned, then the recommendation here is to invest more money in GMT, allowing for more time using that telescope for the American astronomers. Okay. This report makes a lot of other recommendations too, so let's go through some of them super quickly now. A new, more sensitive neutrino detector is recommended as a successor to IceCube. They essentially want to build IceCube 2. Additionally, this detector should be able to tell which astrophysical object a neutrino comes from, even if they just detect one neutrino. A new, more sensitive and powerful ground-based gravitational wave detector, such as Cosmic Explorer, is recommended as a successor to LIGO. A ground-based cosmic microwave background detector at the South Pole, a CMB Stage 4, is also recommended to study the B-mode polarization in the CMB to probe inflation, and it may shed more light on the cosmic neutrino background as well. Also in the report is a new array of radio telescopes, the simply named Next Generation Very Large Array, which could resolve protoplanetary disks 20 times better than the current ALMA array, and would be world-leading. There is also emphasis in the report of the importance of funding and developing real and virtual tools like simulations, data analysis, machine learning, citizen science, and much more. Because having the best telescopes is one thing, but if you can't do anything useful with all of the data they give you, then it's all for nothing. ASTRO2020 also makes recommendations for how governments, universities, and funding agencies should treat the astronomical community, which boils down to much better funding for students, support staff, and early career researchers, vastly improving the abysmal diversity in the field, for example, introducing more diversity criteria when awarding grants, and generally stop treating all of the underpaid and stressed out astronomers like actual trash. Astronomers are human, and they deserve to be treated as such. There's also a specific line that calls for a new model for respectful, collaborative decision-making in partnership with indigenous and other local communities. The people trying to build on Mauna Kea? That one's for you. If I've missed anything that you're excited about in Astro 2020, then let me know in the comments below, and subscribe if you're new to the channel and you enjoyed the video. Until next time, stay safe team. I'll see you soon. Bye!